I want to talk about Antarctica. They are clearly protecting or preserving something that may or may not be under 3 miles of ice.
There's undoubtedly a time when Antarctica was lush and green. The question is, was it lush and green during the lifetime of the human species?
Yes.
And this is where it gets tricky.
Imagine embarking on an expedition to the frozen, remote expanses of Antarctica, only to uncover secrets of a lost civilization that might have thrived there in ancient times. This fascinating theory suggests that parts of a sophisticated ancient civilization could have existed on what is now the icy continent of Antarctica. This idea is tied to the hypothesis of Earth crust displacement,
whereby from time to time, the entire outer crust of the Earth, like the skin of an orange, might shift, leaving the core of the Earth in place.
indicating that Antarctica wasn't always positioned at the South Pole, but might have enjoyed a more temperate climate long ago, making it hospitable for human life. However, this theory is not without its controversies.
Does it happen at all is the first question. I mean, of all the theories I've looked at and supported, this is the one that I've come in for the most criticism for.
The concept of such dramatic geographical shifts is viewed by the scientific community as highly speculative and lacking in solid geological evidence. The current understanding of plate tectonics does not support the possibility of the Earth's crust moving so drastically and quickly to reposition an entire continent from a temperate zone to the South Pole. But the theory delves deeper than just geography. It explores global myths, legends, and religious texts, interpreting them as potential clues to the existence of this ancient civilization. Tales of great floods and cataclysms found in these stories are not seen as mere fiction, but as allegorical records of real events that led to the downfall of this advanced society.
The most important issue to me is the issue of a global cataclysm at the end of the Ice Age.
It is hypothesized that a major disaster, such as a flood or comet impact, could have been the cause of this civilization's disappearance from historical records, with survivors possibly dispersing around the globe and spreading their advanced knowledge to other emerging cultures.
Of course, the most important are the flooded continental shelves. Sea level rose 400 feet at the end of the last ice age. Let's be clear, this was a rise that was extended over a period of 11 or 12,000 years. It did not rise 400 feet overnight.
This leads to another intriguing aspect of the theory, the influence of this lost civilization on later societies. It is believed that the remnants of this ancient society played a significant role in shaping the development of well-known ancient cultures, such as the Egyptians and Sumerians. Similarities in architectural structures and astronomical alignments across different ancient sites are cited as evidence of a shared origin of knowledge. This suggests that these early civilizations might have inherited advanced architectural techniques, astronomical insights, and possibly other lost technologies and wisdom from their predecessors.
The discovery of the technique to do longitudes that actually show the world as it looks during the last ice age suggests that somebody during the last ice age was mapping the world.
Imagine a world where an advanced civilization flourished tens of thousands of years ago, long before the Sumerians of Mesopotamia marked what we consider the dawn of civilization around 6,000 years ago. This bold claim challenges the conventional timeline of history, suggesting that this sophisticated society existed during the last ice age or even earlier, presenting a significant puzzle for mainstream historical narratives that typically view complex societies and state-level civilizations as relatively recent developments. The evidence pointed to is as fascinating as it is controversial. It highlights the architectural marvels of megalithic structures like Göbekli Tepe in Turkey, the iconic Stonehenge in England, and the majestic pyramids of Egypt and Mesoamerica.
One of the many ways that Göbekli Tepe, I think, is going to prove to be a game changer is it's going to require us to reconsider our whole dating sequence on megalithic sites around the world.
These ancient constructs are not just stone monuments but testimonies to an advanced knowledge of architecture, engineering, and astronomy. Precise astronomical alignments of these structures, such as the alignment of the Great Pyramids with Orion's Belt or the solstices and equinoxes at Stonehenge, underscore a sophisticated understanding of the heavens. This expertise suggests that the people who built these monuments had a deep comprehension of celestial bodies, seasons, and cycles. The theory extends beyond monumental architecture. It proposes that this civilization possessed advanced navigational skills, which could explain how similar architectural styles and astronomical knowledge appeared across vast distances, transcending oceans and continents. The scale, precision, and complexity of these megalithic structures indicate technological and engineering skills far beyond what has traditionally been attributed to prehistoric societies. Furthermore, the alignment of ancient monuments with astronomical phenomena hints at a comprehensive grasp of astronomy, deeply integrated into their cultural and religious practices. Evidence of sophisticated urban planning evident in the ruins of ancient cities suggests advanced societal organization and knowledge of city building. The global spread of similar architectural and astronomical insights among disparate ancient cultures indicates a shared source of advanced knowledge. This could have been disseminated by survivors of this prehistoric society, whose legacy might be the foundation upon which later civilizations built their own achievements. Journey back to the Eocene epoch and you'd discover Antarctica vastly different from the icy, remote continent familiar to us today. This fascinating period reveals a past where Antarctica wasn't engulfed in ice but was bustling with life. During the Eocene, Antarctica occupied the same position over the South Pole as it does currently. Yet the global climate was substantially warmer, enabling the continent to support a climate far removed from the frozen desert we recognize now.
There was a lush rainforest that is now covered in miles of ice.
Yeah, that's probably true. The Earth's climate was very different from how it is today.
This era marked a time of significant change, with continental drift following the breakup of the supercontinent Pangaea. As part of the Gondwana fragment, Antarctica was gradually moving to its present isolated position, while continents like Australia and South America began to drift away, modifying ocean currents and climatic conditions. A notable difference from today's Antarctica was the absence of the vast ice sheet that currently covers the continent. The Eocene's elevated global temperatures meant Antarctica was devoid of this extensive ice cover, which had profound implications for the planet's climate. The lack of ice's high albedo effect, which reflects solar radiation, resulted in an even warmer Earth's climate. The tectonic activity during the Eocene was crucial in reshaping our world. The breakup of Gondwana persisted, and the formation of the Drake Passage between Antarctica and South America began to physically isolate the continent. This isolation marked a critical juncture in Antarctica's climatic history. Another significant development was the formation of the Antarctic Circumpolar Current towards the end of the Eocene, or at the beginning of the Oligocene. As the world's largest ocean current encircling Antarctica, the ACC played a vital role in the thermal isolation of the continent. By circulating cold water, it established a climatic barrier that kept warmer waters at bay, leading to the cooling and eventual glaciation of Antarctica. Fossil evidence breathes life into the Eocene Antarctica, with forests of beeches, conifers and ferns indicating a much warmer and more humid climate than today's icy conditions. These fossils, including those of plants and pollen, demonstrate that the continent once supported a diverse range of flora and fauna. Sea levels during the Eocene were significantly higher due to the absence of large ice caps and the warmer global temperatures. This resulted in different coastal configurations, with areas now above water being submerged at that time. The elevated sea levels and warmer temperatures fostered a rich and diverse marine ecosystem, distinct from the current Antarctic marine life. Thus, when we contemplate Antarctica today, it's essential to remember that this icy continent once experienced a vastly different past, one that was warmer, brimming with life, and played a pivotal role in Earth's geological and climatic history. The Eocene epoch, a captivating chapter in Earth's history characterized by dramatic climatic shifts and significant transformations in life on our planet. This period, stretching from about 56 to 34 million years ago, is nestled within the Paleogene period of the Cenozoic era, famously known as the Age of Mammals. This era marked the flourishing of mammals, taking the stage after the dinosaurs exited at the end of the Cretaceous period. The Eocene sits between the Paleocene and the Oligocene epochs, with each phase documenting crucial geological, climatic, and biological shifts. Tectonic plates were on the move towards their current positions, influencing the oceans and sculpting the climate in profound ways. A notable event of this epoch was the Paleocene-Eocene thermal maximum, which occurred around 56 million years ago. Imagine Earth undergoing a sudden temperature surge, with temperatures increasing by 5 to 8 degrees Celsius in just a few thousand years, likely due to a massive release of methane from oceanic methane clathrates. This event significantly impacted ecosystems, leading to the extinction of some species while triggering rapid evolution and diversification in others, especially among mammals. During the Eocene, the atmosphere was laden with CO2, with levels ranging between 1,000 to 2,000 parts per million, far exceeding the pre-industrial levels of about 280 ppm. High CO2 levels, driven by volcanic activity, the combustion of organic matter, and the declining efficiency of carbon sinks, enveloped the Earth in a greenhouse climate. This led to rising temperatures, altering weather patterns and ocean currents, and crafting a world vastly different from our own. The Eocene's warmer conditions had significant effects on marine life. Temperature changes affected marine currents, altering species distribution and fostering the development of new ecosystems. It was a period of change, new beginnings, and dramatic shifts that laid the groundwork for the planet's future. The Eocene epoch, with its stories of warming, shifting, and evolving, serves as a reminder of the dynamic and ever-changing nature of Earth. Antarctica, a vast icy expanse at the southernmost tip of our planet, but beneath its frosty exterior, this continent holds secrets that have baffled and fascinated scientists for decades. Around 34 million years ago, this frigid wasteland was nothing like it is today. Instead of the relentless snow and glaciers we associate with Antarctica, imagine a place teeming with lush forests, diverse flora, and even dinosaurs. That's right. Fossil records show that before its deep freeze, Antarctica was a thriving ecosystem with various prehistoric creatures. So, how did this transformation from forested to frozen happen? It all comes down to the Earth's shifting tectonic plates. As Antarctica drifted southward, it gradually became isolated from the other continents by the vast Southern Ocean. This separation led to the development of the cold Antarctic circumpolar current, which acted like a chilly moat, preserving the icy interior and locking Antarctica into its frosty fate. Yet, Antarctica isn't just a land of ice and snow. It's also a land of mystery. Over the years, scientists have uncovered remnants of its warmer past, fossilized plants, ancient pollen, and even evidence of dinosaur habitats. These discoveries challenge our perceptions and push us to reimagine the dynamic life that once flourished on this frozen continent. When we think of evidence, we often think of concrete, undeniable proof. In Antarctica's case, the evidence of its tropical past is embedded deep beneath its icy crust. The first clues came in the form of coal. Now, coal might seem like a mundane discovery, but think about its origin. Coal is formed from the remains of vegetation that lived and died in swampy tropical conditions hundreds of millions of years ago. Finding coal in Antarctica means that there were once swamps and forests, where now there's just ice. Then there's the petrified wood. In the Transantarctic Mountains, scientists have discovered trees that existed over 250 million years ago during the Permian period. These weren't just any trees, they were relatives of today's ginkgo trees. Just imagine, ancient ginkgo swaying gently under the Antarctic sun. But perhaps the most captivating evidence are the fossils of ancient creatures. Dinosaurs like the Cryolophosaurus, a meat-eating theropod, once roamed this region. Not to mention the different marine reptiles and varied plant life which paint a vivid picture of a lively, thriving, and above all, green Antarctica. Plants. They're the silent witnesses of Earth's extensive history, and in Antarctica they provide compelling evidence of a jungle-like past. As scientists ventured into the depths of Antarctica, they came across something astonishing: fossilized imprints of plants. But these weren't the remnants of cold-resistant flora. These were the ghosts of ferns, palms, and even members of the baobab family. Imagine, where we now see a frozen expanse, there was once a dense forest canopy, filled with sounds of rustling leaves and chirping birds. One incredible find was the Glossopteris. This plant, characterized by its tongue-shaped leaves, thrived during the Permian period, around 300 million years ago. The discovery of Glossopteris fossils in Antarctica, and interestingly, in other southern continents like South America, Africa, and India, paints a tale of the supercontinent Pangaea. But the flora's story doesn't stop there. Layers of sediment also reveal pollen and spores, an indication of the plant diversity that once existed. From giant horsetails to thick conifer forests, the Antarctic landscape was a haven for a myriad of plant life. These remnants are more than just fossils. They are a direct portal, a tangible connection to a time when Antarctica was draped in green, its air thick with humidity, and echoing with the life sounds of a tropical jungle. Earth, as we know it today, is quite different from what it looked like millions of years ago. Continents were cozy neighbors, forming massive land masses. And Antarctica, well, it was in a much warmer position. The concept of plate tectonics is fundamental to understanding Earth's history. It's like Earth's puzzle, where the pieces, continental plates, are constantly, albeit slowly, moving. The movement of these plates has been responsible for the creation and destruction of landmasses over eons. One of the most renowned supercontinents was Pangaea. Around 300 million years ago, this gigantic landmass held most of Earth's continents together, and our mysterious Antarctica was nestled right there, joined with present-day South America, Africa, and Australia. But how can we be so sure of these prehistoric configurations? Rocks, specifically rock formations that match across different continents. For instance, the rocks found in Antarctica have siblings in parts of South America and Africa, suggesting they were once part of the same land. As Pangaea began to break apart due to the churning movements beneath the Earth's crust, Antarctica started its journey southward, eventually ending up at the pole. And as it drifted, the climate changed drastically, leading to the icy continent we recognize today. Plate tectonics have shaped our world, crafted its history, and will continue to mold its future. It's a reminder that Earth is always in flux, forever evolving, and never truly static. When we picture Antarctica today, we think of penguins, seals, and perhaps a lost scientist or two. But travel back in time and you'll be met with a radically different cast of characters. The discovery of ancient animal fossils in Antarctica has been nothing short of astounding. It paints a picture of a teeming landscape, a polar paradise where cold-loving animals were nowhere to be seen. Instead, imagine roaming dinosaurs, dense forests echoing with the calls of varied avian life, and vast waters swimming with reptiles. One of the most famous discoveries was the Antarctic Cryolophosaurus, a large theropod dinosaur with a unique crest on its head. This predator, existing around 190 million years ago during the early Jurassic period, offers substantial evidence that dinosaurs once roamed this now icy land. But it wasn't just on land. The Antarctic waters teemed with life too. Elasmosaurs, a type of long-necked marine reptile, cruised the ancient seas alongside other marine reptiles like ichthyosaurs and plesiosaurs. This tells us that the waters around ancient Antarctica were relatively warm, facilitating a diverse marine ecosystem. And remarkably, evidence also points towards forests that once grew here. With fossilized tree remains and pollen grains, we can imagine a lush landscape, possibly similar to the temperate forests of New Zealand today. It makes one wonder, what dramatic turn of events led from thriving forests and roaming dinosaurs to the barren, icy wasteland we see today? The ever-changing Earth holds its secrets close, with Antarctica serving as a poignant testament to its dynamic history. Around 200 million years ago, Antarctica was part of the supercontinent Pangaea. It was situated farther north, experiencing a much warmer climate than it does today. As the supercontinent began to break apart, Antarctica gradually drifted southward. With its southerly migration, it grew isolated and cold. By around 34 million years ago, the first major ice sheets began to form, starting with the East Antarctic ice sheet. This was a tipping point, a transformation from greenery to a blanket of ice. The formation of the Antarctic circumpolar current played a key role in this. As Antarctica separated from South America and Australia, oceanic currents could flow freely around it, effectively trapping the cold waters and preventing warmer equatorial waters from mixing in. Another factor, the decreasing levels of carbon dioxide in the atmosphere. CO2 acts as a greenhouse gas, trapping heat. With less of it, Earth's temperature began to drop, further favoring ice formation in Antarctica. Our current understanding of climate change, powered by human activities, points to an undeniable increase in global temperatures. With polar regions being particularly sensitive to these changes, it raises a question. Could Antarctica's buried past be its future? Today, accelerated glacial melting is evident, while the re-emergence of a forested Antarctica within our lifetimes is unlikely. These changes signal a shift. Should warming trends continue, we could witness significant reductions in Antarctic ice. Such reductions not only alter Antarctica's landscape, but have wider implications. Rising sea levels, changing global weather patterns, and the loss of habitats for polar species are just some potential consequences. However, in this changing landscape lies an opportunity. As ice recedes, it unveils more secrets from its tropical past. Scientists can access better preserved fossils, revealing more about Earth's history and, in turn, aiding predictions about our planet's future. As we gaze upon Antarctica's vast icy wilderness, we are reminded of the impermanence of its state. It stands as a testament to Earth's dynamic nature and its ability to transform over epochs. But with our recent influence on the climate, the pace of that change is now being tested more than ever.